Hi, I'm Rick, the Rockhound Realtor. Feel free to click on the links below and follow us, and subscribe, and check out our links to our real estate business. And real estate is what sponsors all of our rockhounding tours that we do. So feel free to follow us and send us real estate questions in business. Appreciate it. Thanks. Today we're going to talk about how to identify minerals and some of the tests that are used in doing that. We're going to start with the definition of a mineral. A mineral, one definition that's often used for minerals is it is an inorganic homogeneous solid with a defined chemical composition, a set crystal structure, and is naturally occurring. That sounds like a big mouthful, but it's not really that hard. So a mineral is an inorganic, just meaning that it's not organic. It didn't come from anything organic. So organic homogeneous just means mixed well, that it can't be separated out into another mineral. Solid, that means that it's not a liquid or a gas. With a defined chemical composition, every mineral has its own chemical composition. Just like water has the composition of H2O. If you add something or subtract something to that, like H2O2, add an oxygen to it, then it's no longer water, it's hydrogen peroxide. So, and they also have a set crystal structure. There are 6 crystal classes, and each of them have their own definition, and we'll cover that in a different video. And it's naturally occurring. That's the last part of the definition, is it has to be naturally occurring. And that just means it can't be formed or made by man, so it's just naturally occurring. It forms in nature all by itself. So we're going to start with color. Color is an important part of identifying a mineral. And a lot of people, and I even had a mineralogy professor that would tell me color was irrelevant. But color really isn't irrelevant for identifying minerals. The colors they are often an indication of what they are made up of. And so there are 3 basic causes of color in minerals, or in anything for that matter, but in minerals there's 3 basic causes. One is it can be made, the color is caused by the chemical composition of it, so what it's made up of. For example, copper can often causes the color blue or the color green in minerals, and so most copper minerals are blue or green, but that doesn't mean all blue and green minerals are copper. So, but azurite, blue, one of the most common minerals that we find, one of the most collectible minerals that people like to find, is that blue is because of the color, and that's what causes that. So it's made up of the chemical composition, and that's called idiochromatic. When a mineral is idiochromatic, it means that the color is caused by the chemical composition. The second thing that causes color in a mineral is impurities. So if you think of quartz, quartz can be, pure quartz is just clear, just like this. And then if you add different trace elements to it, in this case a little bit of iron, you get amethyst. And then the third cause of color is structural, and that is when you have like an opal. And I don't know if you can see this in the video, but there's some opal there. That is caused because of the way that the opal is put together. And here's a piece of labradorite. Again, it's the colors, the play of colors in this is caused by the way the crystals are put together. Okay. Ions of the various metals, transition metals, are what causes a lot of the colors, and depending on the mineral they're coloring, they can be different colors for the same transition metal. In this case, chrome causes emeralds to be green and rubies to be red. So 2 different families of minerals, and little tiny amounts of chrome can have a completely different impact.